Hey everyone, today I'm going to do a quick tutorial, well not really quick, but it will be a tutorial on another precedent. This precedent is going to be similar to the Albadar, I know I said that, I butchered that name wrong, but the Albadar kinetic facade based off the sunlight. It's going to be a bit, it's the same thing but different concept on how it's working. Instead of moving one point, we're going to move two individual points. Sorry about that. So this is the picture of it. Right here, if we look at it, it's this precedent is the Miami City Garage, I think, the City View Garage, and in Miami Design District. So yeah, it has this type of the facade condition where it kind of closes and then opens up here. Um, so yeah, these ones that are darker are a little bit more closed up than these ones. So yeah. Um, the patterns it creates pretty cool, so we're going to do something similar to that. So the way we're going to do it is we're going to do close that out. We're going to study it. Like I said in the first one, we're going to study in how its shape is. So I'm going to right click, open link a new tab. Not link, sorry. Open image a new tab, sorry. Sorry about this, guys. So if we look at it, let's look at it real quick. So we know there's a condition of this void, right, that is changing and variable. And we also know that there's this type of paneled shape. So the first thing I usually do is I usually break, like I said before, I break it down into the shapes. So I know that this is my shape. I can kind of see it, but I don't know what it is. It looks kind of like a rectangle, smushed hexagon. So what I'm going to do is I'm going to now count the number of sides of it. So I count this as 1, 2, 3, 4, 5, 6. So I know it's basically, this is another hexagon. It's just a very flattened version of a hexagon. So let's do that real quick. Let's do a hexagon. So hexagonal, we're going to start the same way. And we're going to keep the gridding at that. This extent x, extent y. So we're going to do 5 by 5. Extend it each way. And then we're good. Alright, cool. So we're going to start this hexagonal grid and this 5 for the extent x and the extent y. But you see, it doesn't really look like that right now. If we go back to it, it doesn't really look like that. It has the point on top, while this one, there's no point on the top. So what we're going to have to do is we're going to have to rotate this. So we can rotate this multiple ways. We can rotate it around a center, or we can just kind of rotate it arbitrarily. So we're probably just going to rotate it arbitrarily instead of around, let's say, this center. Just makes it easier. So I'm going to rotate. We're going to rotate the cells 90 degrees. As you can see, it creates that initial shape. Now, obviously, the point isn't this severe in here. We can... do I want to do that in this video? No, it'll be fine. So, in this tutorial, we're just going to keep the shape like this, because technically it is 6 sides, but it's not, right here it is 6 sides, but it's not actually creating the, what's it called? It's 6 sides, but it's not really this, I guess, extreme. As you can see, this has a very large point, while these ones have a very, where's the large point? These ones don't have as large of a point, maybe it's due to the angle, but we're going to keep it like this. The more important, the more important decision making is actually how this void condition is created. Now, what we're really learning here is not the actual shape of this and how to panelize something. We're actually trying to learn how to manipulate this void into any way we want to. So how to start to manipulate the void into, let's say, a bigger void condition versus this small condition of the void. So yeah, that's really what we're trying to get from this. So we rotated it so we have that point. So now we can now explode the geometry. So we're just going to plug in the geometry and the curve, and we're good. So we're going to reference the image a lot. Let me see the image real quickly. So this is the image. I'm going to go down to this one since it's the most clear. We have this. We have this. And we have this. Okay. So what I'm planning to do is draw a center line down here, draw a line down here, and then do a curve intercept or a CCX, and then use attractor points to move those points opposite directions. So let's do that real quick. I'm going to draw a line between here and then here. So first I'm going to do a list item, and I'm going to capture each one of these points. So 1, 2, 3, 4, 5, 6. So at the end of this I should have 6 lists. 2, 3, 4, 5, 6. So all I did was copy and paste a bunch of them, or exactly 6. So the exact amount I would need. So I'm going to do the vertices first. So I'm going to list this, list this, list this, list this one, and finally list this one. So now they're all reading at 0 right now, but let's start with 0. 1, 2, 3, 4, 5. So 5 will go down here. So 0, 1, 2, 3, 4. And I forgot to plug in this one. That's why I was saying. I was wondering why I was counting wrong. So anyways, we have our 0, 1, 2, 3, 4, and 5. So now we can take this line and this line, or this point, and draw a line. So let's do a line component. 0, 1, 2, 3. So this one. So this one and this one. So this point. So now we're just going to draw a point between this point and this point. So as you can see, when we highlight them both, we're just kind of drawing that line there. As you can see, now they're highlighted. Awesome. So now we want to draw a line this way. So what we're going to do is do another list item and find that component. So it should be 1 from what I'm reading, from what I'm assuming. So yeah, it's 1. And then also, it's probably 5 as well, because we know that this point right here, come on, this point is 5, so it's reading 0, 1, 2, 3, 4, 5. Oh, 4, sorry. Yep. Alright, cool. So what we're going to do now is do a divide curve on both those components. And we're going to copy and paste this one. So we have 2 divide curves. And we're going to plug those both in. We're going to get a bunch of points. And then we're going to put 2 in for the count for both of them. Alright, and then we're going to do another list item. After we do a list item, we want to now isolate this curve right here. Or not this curve, sorry, excuse me. We're going to isolate this point so we can draw a line in between here and here. So let's do that real quick. Let's just do a point, and then we can do 1. This will be in between here. 1. And plug in the list into both. So now as you can see, they're highlighting both of those. Now we simply just have to draw a line between the 2. Awesome. So see, we have this line condition now where it's actually starting to intersect, which is cool. So intersect, or no, not intersect, CCX, the curve component, and we're going to plug this one in and plug this one in. So awesome. Sweet. So we have that now. We're going to pay attention to this one. And now we're going to do a move. And we're actually going to move this center point in the vector direction this way. So let's do that real quick. So let's do an amplitude. So we're basically going to do the same thing that we did for the Al-Budai building or Budar building. And instead of, so we're going to do the amplitude. Then we need to set a vector 2pt, a vector 2pt, vector, and then we're good for right now. And then we're going to set a remap numbers, bounds, and construct main. And then we're going to do, after that, we're going to do a distance. So we have point A and point B, so basically point A is that curve that we want to manipulate. It's definitely going to be this one. And then we're going to set our point in Rhino. Or set that point from Rhino to Grasshopper, excuse me. Awesome. So we now have that point referenced, and now we just need that vector point. So we want to know the distance between the center point and, not the center point, yeah, the center point, sorry, and this end point. So we just need to find that list. Alright, this should be it. And then we're going to plug this in. And it's moving, but it's moving linearly. It's not moving it's not moving off of an attractor point for right now. Because if you see, if we do that, and with slide we look at all these points, they all move linearly. They don't move off a tractor point, which is not what we want. So we're going to flatten this one. And we have all of these kind of curves. Then we're going to look at the outcome. So we know that each center point should be 25, from what I'm assuming. The geometry should say 25 locally defined. This one is saying 25 to 625, so it's one of these again. Alright, so it's one of these again, and just like the last lesson, I think it's this one. Just have to graft it or flatten. Okay, that doesn't do anything. That doesn't seem to do anything. So we're going to try grafting this. Let's try flattening. And again, I'm showing my troubleshooting process because I feel this is an important factor. So I may need to flatten this just like I did with the other ones. As you see, it doesn't do anything, so I'm going to Z. Or maybe it's the geometry. Then flatten. Maybe it's flatten. Let me check. Okay. The reason why I flattened that geometry, and let me undo that so it shows why. Now, part of the troubleshooting process is sometimes isolating the problem down to a certain area. So I know it was either this component, or this component that was going wrong. As you can see, this one's reading 625, and this is reading 625. So it has to be either this one, or this one. So I know that it wasn't this one after I did that other initial one, and these two weren't working at all. So sometimes you have to guess between flatten and graft, because right now the list is reading, if we go to a panel, and we go to points, as you can see, the points are readed all grafted. So right now, let's see how it comes out. It's going to come out it's going to come out grouped, like this. No, not fun at all. So it goes from 25 completely grafted branches to 625, and then in certain groups. So I know that I need to either flatten or graft, and then the reason why I picked graft over flatten is because since this panel is grafted, it has to match this component as well. So I know that this had to be grafted or flattened, but it's going to be grafted because of, see how these are grafted as well. They're going to have to be grafted the exact same way. So, because they don't read uniformly. See, as you can see, these don't read very uniform because this is this is one branch and then one component, one branch and one component. This is one branch and a multitude of components, about 25 components each. So it's copying itself 25 times basically. That will make it 625. So what we're going to do is we're going to graft that, or no, sorry, flatten that to get the 25 values, and let's see what it looks like. So yeah, whether I may be wrong or right, I isolated down to these three to understand, to either flatten or graft, and to actually work the script out. You can see this is flattened. Now it's reading 625. That's still reading 625, which is not good. So I don't want that to read 625. So let's see. This one's reading 25. So it has to be, the vector here is still reading 625. I know this is outputting, this is still outputting 625. So it looks right on Grasshopper, right? The points they look like they're working, right? But it's a list issue, so it's a hidden type of issue. So it could be from this. So we know that these two don't do anything. We've already tried that. Have we tried flattening? This one's already flattened, so we may need to flatten that. Nope. Let's try grafting. Now they're all 25 locally defined. Do I need to flatten this still? Okay, maybe I didn't need to flatten that piece because that was still reading the 625 that I didn't need. Now I simplified it down because this is reading 25, this is reading 25, and this is reading 25. So all this is reading 25. Let me see this. All this is reading 25 except for this one, which is reading 625. So it had to be this component. So if we graph, so unflatten that, we get our attractor points, as you can see. And we're going to set it to not 0. We're going to set our construct domain start to something small. So like, oops, that's pretty good. Something really small, like 0.28, 0.02. Cool. So now that we have that done, we have it reading 25 translate geometry, which is exactly what we want. And it's based off an attractor point. Once we do that, we're going to draw our surfaces now. So we know our surface is going to be 1, 2, 3, 4. So let's do that. 4P, and then click that. We have 1, so let's plug that in. We have the top one, which is 2. So we're going to drag that all the way here. 3, which is that list 2 right here. 3. And then the final one, which is this one. Nope, not that one, sorry. Excuse me. It's one of the divide curves, so we're just going to pick one of them. So it's that one. And we're going to shove that in. So cool. We have that. And now we're going to do another one on the opposite side. 4P. And now we're going to do find those. So we're going to get, this one's only moving 1. So we're going to do this bottom one actually, sorry. Not this one because we're trying to just mirror the points. So that's what my plan is. I have this, so if I just do this part, I can just kind of mirror it across instead of recreating this point on the other side by just reversing the script by just reversing the mapped area. So let's do that. We have 1. We have 1, 2, 3, 4, or 0, 1, 2, 3. So let's find that list of 3, which is here. And we're going to plug that right into here. Alright, so 1, 2, 3, so 0, 1, 2. So 2 on that list. Alright, and that should be good. And then the final one, which is just this point. I guess we didn't get that center point. Alright, cool. So now we have these points, as you can see. And they're reading these points right now. So as you can see, we're reading these two surfaces, and we want them to read as one. So we're going to do a join, a prep join, and then we're just going to plug in both of these geometries into what we want it to be. Awesome. So now we have these plugged in, as you can see. Once you do that, we're going to now do a rotate. Same thing. We're going to take the center of these polygons, which is just the CCX. So this is the center technically of the polygon, since we drew those curves based off of the original shape, and we're going to put it under plane. So as you can see, I just hooked up the rotated geometry into the the CCX to the rotated geometry. Once we do that, we're going to pick our geometry. So let's pick that rep. Right now it's only rotating 90, so we're just going to change it from radians to degrees, and then we're going to say 180 degrees. Pretty simple. So now we have that done. Awesome, yeah. And now, so yeah, we have that shape. So if we look back on it, we're kind of creating that facade, how this is more open versus how these are more closed. So we have kind of this closed condition here. So yeah, this is just another study of the of another place. So this is the Miami or City View Garage Miami Design District. So yeah, guys, that's pretty much it for this part. I will be going over another part B on articulating the design and making it more like a thin piece instead of it just reading as one kind of two-dimensional surface. So yeah, that's pretty much it, guys. Thank you guys for watching. Hope you guys have a great day.